So this video is number 9 and 10 on your 2-3 homework. Starting with number 9, at first it may look irreducible or non-factorable, but the first thing I want to look for is there anything that both of those have in common that I can divide out evenly from each term. And so since 10 is divisible by 10 and 80 is divisible by 10, I have a greatest common factor here. So I can rewrite this as 10 parentheses x cubed minus 8. And now that I've pulled out that greatest common factor that they're both divisible by, now I look and I recognize this as one of my special factoring patterns as the difference of two cubes, because I've got the x cubed and then I've got 8, which I know has a cube root, also has a perfect cube. So for that special factoring pattern, I'm going to keep the 10 here so that I don't forget that there's a 10. I'm going to keep that the entire time. And then if I look at my special factoring pattern, the difference of two cubes says that a cubed minus b cubed, where a and b can be anything, that has a perfect cube, is a minus b times a squared plus ab plus b squared. And again, these are not equations you have to have memorized, but you do have to know how to use them. So from what I see here, my a would equal x, because that's the cube root of x cubed is just x. And my b is going to be 2. Because I'm considering b is just that 8, and so the cube root of that, so 2. And so 10 parentheses, this says a minus b, so I'm going to have the x minus 2, close parentheses. And then my a squared, well, a is x, so I have x squared, plus ab, so a times b is 2 times x, plus b squared, which is 4. And that would be your answer for that. Alright, so for number 10, the first thing I'm going to do is look for a greatest common factor again, something that is common between all of the terms. And here I've got x squared that 5x squared has, 7x cubed has at least that, and 2x to the 4th has at least an x squared I can divide out. So I'm going to start by dividing out the x squared. And then I would have 2x squared plus 7x plus 5. And instead of just calling that done and being done with the problem, I'm going to check and make sure that I can't use any other kind of factoring to simplify more that 2x squared plus 7x plus 5. And I can do something here. I know I can't use any special factoring patterns, but I've got a quadratic where a not equal to 1. So I'm going to multiply my a and my c together, and that's that number that goes in my chart, 10. So now I've got to think, I've got a equals 2, b equals 7, and c equals 5. I've got to think about numbers that multiply to be the product of a and c, 10, that add to be 7, which is just going to be 5 and 2. If I add them, I get 7. If I multiply them, I get 10. And instead, I take those two numbers and I break up my 7x into 5x plus 2x. It doesn't matter which one you put first. I'm just choosing to do it this way. And then I've got my 2x squared here, and my x squared still on the outside. Notice nothing else has changed about this problem except the fact that I broke up 7x to be 5x and 2x, which is the same thing. So now from here I've got 4 terms, which means factor by grouping. I'm going to group here and group here. I'm not going to forget about that x squared. I'm going to keep writing it so that I don't make the mistake of forgetting it in my answer. From 2x squared plus 5x, I can pull out an x. And then I just have 2x plus 5 left over. And then my other group is 2x plus 5, whose greatest common factor is just 1. Nothing else divides both of those evenly except for 1. And so then I would have 2x plus 5, which is good because now I have a common binomial factor that I can pull out. And so now I've got this x squared, and I factor out my 2x plus 5, that binomial, those things that match. And if they didn't match, something went wrong with the way we factored. And then x plus 1. And this would be your completely factored number 10.